Yeah, once we have an argumented matrix, we can talk about elementary row operations. I'm gonna come back to this. Right? So you can see the flow chart. That's just basically it all stems from equations. We're just trying to solve these equations. We get an argumented matrix. We're still trying to solve this. And then we talk about elementary row operations so that we have solutions. Maybe let me draw it like this. So that we have solutions. And this is what we're interested in. This. All right. Basically, that's the whole flow chart. That's the whole idea. We have equation and we're trying to find solutions. And we do all this kinds of things in between to finally solve the equations. Then I'm just gonna highlight this one, elementary and the solutions. I'm just gonna make another page here. So we have elementary row operations. We have elementary row operations, and there is 3 of them. There's one. You multiply a row. You multiply a row of a matrix, okay, by a constant. Let's call it k. K belongs to integers. Basically, it's just a number, can be a whole number that can be positive or negative or positive. And then we interchange 2 rows. And then the last one, we add, okay, multiplying a row, it's like, for example, you have, let's say 2. You want to multiply a row by 2. So it's going to be 2, maybe R1. And then interchanging of rows, it's just making maybe row 2 equal row 1, something like this.
Okay.
Then the last one, we add a constant times 1 row to another row, So what we're doing basically here, the idea is we adding what? It says add a constant. So we have a constant, let's say constant 2 times maybe row 1. We add, that's what the statement is saying. So we're adding, what are we adding? We're adding a constant times a row to another row. Let's say row 3. Those are the only operations that are allowed when trying to solve the equations using the argumented matrix. And then from elementary, we said we have solutions. Solutions, it's very important to understand this because I'm just gonna cover I'm gonna cover 2 chapters. It's basically the most difficult chapters in the book, because once you understand this, you are good to go. And I decided to spend more time today because in order for you to understand those confusing things they normally put there on the matrices, you gotta understand what's happening. So now we have solutions, and then solutions, there is only three possibilities. There's only three possibilities. When you're trying to solve the after doing the row operations and all of that, it's either you're gonna get no solution, right? Or let me just write it like this, sorry. So you've got solutions. And then these solutions, you might not have a solution, no solution. Or you might have a unique solution or one solution. Unique solution. Or you might have many solutions, or infinitely many solutions. Many solutions. Yeah. So these are the only three possibilities. There's no other possibility. These are the only three possibilities. I'll show you examples of each of this. So when we have no solution, say we say that the system is inconsistent. Is inconsistent. Then if you have many solutions or unique solution, we say that the system is consistent, which means it consistent, it exists. Consistent, it means it's just there's something wrong, it doesn't exist, in other words. Yeah. So basically, that's what we have. And then through this thing, the elementary row operations, we encounter something, it's like a method. It's like a method of solving these equations. We encounter something called Gaussian? Hope I'm pronouncing it correct. Gaussian elimination. Yeah. Then let's just see what is this Gaussian elimination. Basically, Gaussian elimination Gaussian elimination is just a method that says, okay, look, you have so many equations, a system of equations, you have these equations, you have created a matrix. So this is how you're gonna solve. It says, first of all, you look for any rows that have zeros in them, only zeros. And then you just, so rows with zeros, you group them at the end. You group them at the end of the matrix. Basically, you stack them towards the end, and then it says, okay, once you have done that, the next row, or the first row, must have a non-zero number as a leading one. The first non-zero number is a leading one. And the third, we'll say this is the first row. First row. And then any other row that comes after this, whether the second or third, it must be in such a way that the leading one of that row occurs to the right. Occurs to the right compared to the upper row. Compared to the, let me just say previous row. Or upper row. Once you've done something like this, it's gonna look, it might look something like this. Let me show you an example. It might look something like this. We've got a leading one. Maybe we've got a 2, we've got a 3, maybe we've got a 4. Then we've got a 0 here. Got a 0. Let's say we've got a 1, got a 7, and we've got an 8. Then we've got a 0 here. Maybe we've got a 1 here. Then we've got a 9. Something like this. Basically, what it says is if you have a leading one, the next leading one must be to the right. It could be here, in this case it's here, but it doesn't necessarily have to be here all the time. You could have a 0 here, and then the 1 could be here in place of 7. It will still fall under Gaussian elimination. The next one again will fall on the right relative to the previous row. So it's something like this. When it's like this, it's called when it's in this form, we say it's in what am I doing? This whole thing, these 3. Oh man, this is terrible. These 3, there's an example of these 3. We call the matrix to be in row echelon. Is it echelon? It's an echelon form, right? But then we could go a step further, and we can say each column, you see these columns, these ones we call them, these ones that I have highlighted, we call them leading ones. Leading ones, basically they are leading their rows. Because here is a 0, a 0 cannot lead. They are leading their rows. But you can see that below these ones, there's 0, only zeros. Then below this one, there's a 0. This one is the last one, so there can't be a 0 below. But you can see on top there are numbers, right? We could go a step further and do the elementary row operations again and receive zeros on top. And like below and above the leading one, we could have zeros. Once we do that, if we each column with a leading one as zeros, everywhere else in the column. This, once we go a step further, this we're gonna call it reduced row echelon. So echelon form. And that's something like this. This case would be 1 0 0 0 1 0 0 0 1. Then might have 3 2 8, something like that. It's a reduced row echelon form, and basically that's it. That's like the summary. And huh?
No, I said it's fine. Because I think I was swapping these whole, like the reduced and row. I think at some point I was swapping them around. I thought it was the same thing. I thought the Gaussian and the row thingy was the same thing, but it is actually the same thing. Then I thought it was the same as the reduced one as well, but I can see the difference now.
Oh, like the Gaussian elimination actually, it actually Gaussian elimination. The Gaussian elimination actually ends at number 3. And then number 4, the reduced row echelon form, it's called, once you include step 4, once you include this one, it's actually called, is it gas Jordan? Is it Jordan?
Oh, okay, I
Jordan
remember that name. Yes, it is Gaussian. I thought this
elimination.
was the same thing.
Now the Gauss Jordan elimination, it's when it's in reduced form. And then
Okay.
a Gaussian elimination, it's basically it's the row echelon form. It's number 1 to number 3.
All right.
Yeah. Yeah, basically, let me just, oh yeah, let me just write it. Let me just write this last thing, and then we can do examples and try solving. Just facts about facts about echelon forms. So basically, let me just go back here. Basically here, what's important is these two words, row echelon form and reduced row echelon form. You're gonna understand what is the meaning. I'm gonna show you examples on the book, but let me just finish mentioning a few facts. There's like 3 of them. Fact number 1 is that every matrix has a unique reduced, see the word reduced, very important, row echelon form. You know, reduced, right? So every matrix will have a different, if you it's like you've got 2 different matrices. If you do the row reduction until you reduce everything, they're gonna be different. But it's not the case for row. You see, row doesn't have reduce next to it. Or row echelon form
Yeah.
is the one that doesn't have zeros everywhere, only has zeros below. Are not unique. Which means you could do it in different ways to reach to the same answer. Someone could reduce it their own way that is much simpler. Someone could reduce it they could reduce it their own way. It's not unique, but this one will always be the same. If it's reduced, it will always be the same. And then, this one, both of them, they have they have the same, they will have the same number of, they will have the same number of zero rows, and the leading ones, okay, at the same positions. Yeah, let's just sum back now. Let's just go back now to are you taking notes?
Yep.
Okay, let me just give you a second.
Yeah, I'm done. I'm quite a fast writer.
So this is the summary, basically equations, all of these we do a lot of things in between, we are trying to find solutions. The most important thing is the solutions. So now we need to focus on the solutions. I said the solution there are three situations. So I'm gonna show you all three of them.
Okay.
It's quite important. The solution, I hope this thing doesn't actually check. They say it cuts after 40 minutes. Then what the hell is going on, man?
Oh yeah,
Oh shit.
and I think we've reached about 30 minutes right now.
Oh, it says it's gonna end in 10
Around
minutes.
30 minutes there.
It just popped. It says it's gonna end after 10 minutes. So I think we'll be done with some of the examples. Then we can restart it again.
Okay.
Yeah.
Okay, no problem.
I used to just ignore this thing. It actually has a timer here saying the amount of time remaining. Anyways, it says 9 minutes right now. We have solutions, right? Let me just do it some sort of a diagram. Uh, let's say it's a two-dimensional system, but we're gonna work with three-dimensional, and it applies to all kinds of system, idea. Then we've got a line and then another line. Then they intersect. These ones are parallel. And then we have the dead one, where they just, it's like they are on top of each other. I don't know how to do it. I'm just gonna do this. If they're like this, we say it's one solution or unique, one solution. And then when they're like this, there's no solution because they don't intersect. No solution. And then the dead one, if they are stacked on top of each other, that's when we have many solutions. Many solutions. Let me just, we'll have an example here. Okay, let's just start with the one that has infinitely many solutions. Oh wait, let's start with this one. I think it's a good one. This one without solution.
Okay.
Imagine we have a system of equations. 2x minus 2y plus 6z equal 10. Yeah. Then we've got 3x minus 5 y plus 12 equal minus 6. Then we've got 4x minus 4y plus 12z equal 18. And then we create an augmented matrix using this. Basically we remove all the variables and we're left with the constants on the numbers. 6, 10.
The other 12 is supposed to have a Z, right?
Sorry?
Or are we going to take it over?
I can't hear you.
Hello?
Hello? Yeah, I can hear you. What I say?
No, I mean, there's a 12 there that you didn't. Are we going to take it over since you didn't put the Z? Can you, no, I was talking about the 12 there. I thought you didn't put a Z. So honestly, I thought maybe you were going to take it over. Okay, never mind. Okay, it was just like, fine.
Okay, yeah. So now we try solving this using the elementary row operations. The idea is to have 1 at the beginning here. Now we could get a 1 by, for example, dividing everything by 2. Let me just do that. But I'm gonna show you other tricks of solving this thing. In this case, we see when you divide by 2, there's no fractions, so it would be nice and simple. You don't have to write a lot of things. You just have to do it in your mind. You know what you're doing. Minus 1, and then 3, it's 5, right? Then 3, minus 5, 12, minus 6, then 4. Oh, wait, we should actually divide this one by 2. But let me just leave it like this. 4 minus 4, 12, 18, right? And then now we have a leading one. So we want the numbers below that one to be 0. So what are we gonna do? We're gonna say negative. You see this number, take this number, you put a negative, multiply the first row. You normally do it, you do it inside your head, but let me just do it here. Minus 3, 3, because it's just like a waste of writing and stuff. Normally you just do it in your head. Then it's gonna be minus 9, and then it's gonna be, what is this? Minus 3 times 5. It's minus 15. Then we've got the 3 here, minus 4, 12, minus 6, 4, minus 4.
I can't hear you. Keep cutting off.
Oh, you can't hear me? Hello?
No, like sometimes you do cut. Like it does that squeeze thingy and then it comes back again. I don't know if you can even hear me at times.
Let me just use my headset because I'm using the speaker.
Oh,
Hello? Hello?
yeah, I can hear you.
Yeah, I
Can
think
you hear me?
yeah, I think you're also cutting a bit.
Oh.
Yeah, but I can hear you.
Oh.
I'm just trying to increase the volume. So this is gonna be what? We don't change this one. And then we add these two. We replace the second row. The idea is to replace the second and the third row. So we're just gonna write this one, the one that has 1. This step you normally, I'm just doing it so that you see. You don't normally write it down. You just do it in your head.
Okay.
5. So this is what you would do in your head. You just say minus 3 times 1 plus 3 would be 0. And then you say minus 3 times minus 1, which is 3. And then you add it to minus 5, which is minus 2. It's easier here because you can see it. So it's 12, it's 9, minus 9 plus 12, which is 3. And minus 5 plus minus 6, which is minus 21. Right? And then you do the same thing with 4. You're gonna do it inside your head. So this thing, it avoids writing a lot of this thing. So you can just do it in one go. Let me just quickly do it. My time is running out for this one. So minus 4 times minus 4, see this 4, put a negative. You multiply the first row as well. Minus 4 times 1 plus 4, it's gonna be 0. Minus 4 times minus 1, it's 4, plus minus 4 is 0. Minus 4 times minus 3, it's minus 12, plus 12 is 0. Minus 4 times minus 4, oh, dang, minus 4 times 5, that's what is it, minus 20, plus 18, it's minus 2. Okay, let me just stop this. Okay, let me just let it cut because